Alright, so we're going to continue on with section 7.2, which is solving by graphing. And we're going to start with this word problem. So we had a plane left Regina at noon to travel 1,400 miles to Ottawa at an average speed of 400 miles per hour. Another plane left Ottawa at the same time to travel to Regina at an average speed of 350. So one is leaving Ottawa going to Regina, the other is leaving Regina and going to Ottawa. We want to find, and those are represented by these two situations. So this is plane 1 and this is plane 2. So we have the equations. D is the distance in miles from Ottawa, and T is the time in hours since the plane took off. The first thing we should do is put the independent and dependent variables on our graph. Remember these words, independent and dependent? Remember that independent is the x. So the independent in this case would be t, because that's the time, right? And then the dependent variable would be d. So remember that the independent always goes on the bottom, so the time is going to go on the bottom, and the distance, the dependent, will go on the side. So let's start by finding the intercepts of the first equation, 1,400 minus 400t. So to find the d-intercept, we'd have to set t equal to 0, because we always set the opposite one to be 0. So that means we're going to get d equals 1,400, subtract 400 times 0, but that really means nothing. So we have d equals 1,400. So the d-intercept for the first equation is 1,400. Then we can find the t-intercept, and we again set the opposite equal to 0. So we're going to put the d part equal to 0. That means we get 0 equals 1,400 minus 400t. And now we're going to manipulate the equation. So we end up with a t-intercept of 3.5 hours. We'll put those on the graph. So once we have our graph set up, we can put the d-intercept at 1,400 and the t-intercept at 3.5, and then we can just connect them with a nice straight line. Okay, so for our next one, then we have to find the intercept. So to find the t-intercept, I put d equal to 0. And then if I divide out the 350 to the other side, we just get 0 is the t-intercept. Now this is kind of weird because if you think about your graph, that means that the d-intercept is also 0, right? Because that's this point right here. So if that's your intercept of x, that's also your intercept of y. So it's not really going to help us to find our other intercept, because that is the other intercept. So from here, we're going to have to actually calculate by counting the rise over the run. Now the slope of this question is 350 over 1. So the rise is 350, the run is 1. So from 0, I'll go up 350 over 1. Then I'll go up another 350 to 700 and over 1. Again, you could go up another 350 and over 1. And you get a line that's something like that. Alright, so we graphed it. Now we should be able to find our answer. Our answer is where these two cross. Now it's going to depend how neat your graph is to find exactly where they cross and how accurate it is. So we're kind of taking a guess here because it doesn't appear to be a nice spot. So this one looks to be not quite 2 and maybe 650?
Yeah.
Would we say maybe like 1.75 and 650 or something like that? Were they neat? Again, look at your page and see what you think. So it says, when do the planes pass each other and how far are they from Ottawa? So again, basically what we've said here is I picked the point 1.75 and 650. So what this means is it's been 1.75 hours and 650 miles from Ottawa. Now, how could you check if you're right? You plug them back in. So if I plug them into it's called verify. So I'm going to verify by plugging these back in. Okay, so you can see that my answer is not quite right, which means that this answer that I picked for my graph is off. So I do understand that graphing is probably not the best way to do a question like this because it's hard to find your answers. Let's try one more anyways. This one, example 3. we have a visit to the Science Center has an administration fee of $5 for a student and $9 for an adult. In 1 hour, 32 people enter, and a total of $180 were collected. So here we have to make up our own equations. So for this one, we have two things. We have x and we have y. What should we make x and what should we make y? Alright, so you should get these then for your equations. The students plus the adults is going to equal 32. And at $5 a student and $9 for an adult, we'll get $180 altogether. So this one I think we should graph using x and y intercepts.
What should be labeled on graph?
So here's the video showing your x and your y intercepts. You can pause the video here if you need some time to take a read through that. So then we can just plot our intercepts and find where our two graphs cross. Where they cross is at 27 and 5. So that means 27 students entered the Science Center and 5 adults. If you would check by plugging them in for your x's and y's, sorry, 27 and 5, both of your equations should work out as well. So you can then do page 409, number 3 to 6, and 8 and 12.